Today we're going to learn about graphing polynomials. So on the last video we found the x-intercepts for the polynomial, which we will need for graphing the polynomial. So we have the function f of x equals x cubed minus 5x squared plus 7x minus 3. So there's three things we must find in order to graph a polynomial. We need to find 1, the end behavior, 2, the x-intercept and y-intercept, and 3, if the x-intercept crosses or bounces the x-intercept, also known as the multiplicity. So first thing I'm going to check is the end behavior. So I'm going to put it on the left. So to find the end behavior, you look at the highest degree, which is x cubed, right? X cubed. And we all know, and this is, the degree is odd, so we all know that it's going to rise to the right and decrease to the left, right? So it's going to look something like this. Right? So that's what a typical x cubed looks like. Okay, now we got to notice that the coefficient, it's just 1, right? There's an invisible 1. Now, if we don't care about the number, we only care if it's positive or negative. So in this case, it's positive. If it was negative, there's a reflection, right? So if it was negative, it would look something like this. But since it's positive, we only care about this. We only care about if it's positive or negative. So now next step is finding the x-intercept and y-intercept. The y-intercept is easy. All you got to do is plug in 0 into the function, right? And then the x-intercept, there's either two ways to find the x-intercept. We got to find the we can either use synthetic division using the p over q, or we could do grouping by factoring. And I'm looking at it, and it's x cubed minus 5x squared plus 7x minus 3. If I break it into 2, I could factor out an x squared, right? X squared from the first part, but if I look at the second part, the 7x minus 3, I can't factor out anything. So we cannot do grouping by factoring, so we're going to have to do synthetic division. So for synthetic division, we got to find out our p and our q, right? So our p is is 3, right? Our p is 3 and our q is 1. So so the factors of 3 is plus and minus 1 and 3. And our q is one, so it's just plus or minus 1. So the rational theorem states it's p over q, so p over q equals, so it's just 1 over 1 and then 3 over 1, which is just plus or minus 1 and 3. So these are our factors, and now I'm going to figure out, I am going to try using, positive 1. So I'm going to use synthetic division, right? And in order to do synthetic division, we got to check if everything's ordered. So we have an x cubed minus 5x squared plus 7x minus 3. So everything's ordered. Now we're just going to write the coefficients. So it's 1 -5, 7, and -3. Put my line under, bring down the 0, 1, bring down 0 plus 1 is 1, 1 times 1 is 1, -5 plus 1 is -4, -4 times 1 is -4, 7 minus 4 is 3, positive 3, 3 times 1 is 3, and then -3 plus 3 is 0. Voila, we have a factor because we don't have a 0, we have a remainder of 0. So our new equation is f of x. So these are coefficients, and then our degree is always 1 less from the original. So it's, instead of cube, it's going to be x squared, right? 1x squared. I'll just write it as x squared. And then and then you just keep going down 1 degree. So it's -4x plus 3 multiplied by the one we factored. Now it's not going to be plus 1, it's always the opposite, so it's x minus 1, right? It's always the opposite. And then this, we can actually factor the x squared minus 4x plus 3. Really simple. We do not have to do synthetic division again. That's x, and then I'm going to use -1 and -3, right? Because -1 times -3 is positive 3, and when added gives you -4. 1 and then -3. And then x minus 1. Good. So our x-intercept equals, hold on, I can actually rewrite this again. So you notice how we have an x minus 1 twice, so I could write that, I'll just write it, instead of writing it over again, I'm just going to square it, and then I just got to erase this. Okay, so our x-intercept is 1, but we have like 2 1s, right? And positive 3. Now we should have a total of 3 answers, which we do, but I only wrote x once, so I could write it again if I want to. So this form is really important because this will determine our multiplicity, and this will determine if it bounces or crosses. So let's start graphing. Before I graph, I gotta look at let's find our y-intercept. So to find the y-intercept, you simply plug in 0 for the function. So 0 cubed is 0, right? right? 0 cubed is 0. Minus 5 is 0 squared, which is 0. Plus 7 times 0 is 0. So you're just left with negative 3. So it should be, our y-intercept is 0, comma, negative 3. Okay. So let me just erase some of these. Okay. So we know the end behavior, we know our x and y intercept. Now we'll just graph it. So I will plot the y-intercept, so it's right around here, right? And then our x-intercept is run here. Here's 1. And positive 3 is right here. Now I'm going to graph my end behavior. So it's an x cubed, so it rises to the right, like that, and decreases to the left, like that. Okay, now I gotta determine if it bounces or when it crosses the x-intercept. So where we got 1, we got it from here, from the x minus 1 square. So it has an even multiplicity. So when it's an even multiplicity, it bounces the x-intercept. So it's going to look something like this. Bounce. Right? And then now our next one is where we got the positive 3. We got it from here. And now it has a 1 multiplicity. And it's odd, so it will cross the x-intercept. So bounce right from there, and then kaboom, crosses it. And that's pretty much how you graph a polynomial.